water, the dust, and the food. Those are sort of the main pathways of your potential exposure. Within each one of those compartments, the calculations depend on estimates. You have to estimate some things. For example, food. You have to estimate how much is going to be in the food you eat in the course of a day, in the course of a week, in the course of a year, in the course of years. And then you have to estimate how much of that lead is actually going to be absorbed into the stomach, through the stomach into the bloodstream. Those are estimates. And there are assumptions made about whether that kind of lead or that species of lead and its absorption rate. The same with dust or air. How much is going to pass from whatever you breathe in through the lungs into your bloodstream? So it's huge estimates and assumptions about the time you spend outdoors, the food you drink, how much water you drink, and it depends on age. So you can imagine in a population the variation that would exist. Huge variation, and all of that variation is averaged down. So they're not looking at you individually. They're looking at the average in a population. So we had risk assessment, non-cancer risks. That's the ones that are other diseases, liver problems, kidney problems, lung problems. And it's measured by the hazard quotient 1. Anything over 1, it's a risk. Falconbridge, Coppercliff, Baldoon. In Baldoon, which is a lead smelter community where the lead levels were twice as high in the water as they were in Falconbridge and Coppercliff, where, see, this is 3.6 is the drinking water. The drinking water in Falconbridge was estimated to be 0.97, 1.3. This is almost more than twice as high. The outdoor air is twice as high in Baldoon as it is in Coppercliff and Falconbridge. The dust levels are 40 or 50% higher. The homegrown vegetables, well, they're kind of about the same. And the amount, the dietary intake is essentially the same. Yet, for Baldoon, the risk is lower than it is for people living in Falconbridge and Coppercliff. How can that be? When the level in the water and the air and the soil is higher in Baldoon, they found the risk to be below 1. But in Coppercliff and Falconbridge, it's above 1. Same model. Same, well, not quite the same assumptions. But it gives you 2 different answers. Now, blood lead levels. Port Colborne, Falconbridge, Coppercliff. Same models. Same, exactly the same, the IUBK model, which is the integrated exposure uptake and biokinetic model. Same model. We asked the Minister of Health to do this type of assessment, and his response to us was, and I'm quoting, it would introduce an element of confusion. Okay, but it was good enough for the people of Port Colborne, and it was good enough for Sudburyans, but clearly not, it would be too confusing for us simple-minded folks in Baldoon. The point I want to make here is the difference between Port Colborne and Falconbridge and Coppercliff. The probability of exceeding blood lead levels of 5, remember, let's not even talk about 10. Anything that exceeds 10 is just, well, it's downright dangerous. 5 is the number we should be focused on. But here we go. In Port Colborne, which had higher drinking levels, higher soil levels, higher dust levels, the probability of exceeding 5 was only a little over 10%. But in Falconbridge and Coppercliff, it was 40 and 60%. Same model, but two different results. This is the problem with health risk assessments. They are imprecise, blunt tools. They're not scalpels. They're not surgical scalpels where you can really get fine details and precise estimates. They're change one aspect of the model and you get very different results. And these are decisions that are not based on science. So the recommendations for soil cleanup levels for lead were 500 in Baldoon, 400 for Sudbury, and we're not sure what it's going to be for Port Colborne. So why do the results vary? This is a quote. And I'm going to tell you where the quote came from in a minute. By altering one or more of these parameters, so this is the soil ingestion, soil to dust, food consumption, bioavailability, by adjusting one or more of these, the risk management level can vary substantially. It is important to note that the selection process behind the choice, that choosing these, most of these input parameters is largely based on policy, not science. And this was, where did this quote come from? The Sudbury Area Risk Assessment Study. The risk assessment study said, this isn't about science. This is about policy. And what does policy mean? It's what it is essentially about politics. Because policy isn't about science. Policy is about government negotiating with its stakeholders to the lowest common denominator. Because science tells us that the limit should be 5 micrograms per deciliter for the medical level of concern. The science tells us that 140 parts per million should be what we're using, but this process negotiates all of that away. Just a little example of where policy conflicts with science. This is from the SARA report. This is the lifetime health risk for non-cancer diseases for infants, toddlers, children, adolescents, and adults for the Sudbury Centre area. The risk assessment argues that we're not going to use what the Department of Environment says is the risk level, which is 0.2. We're going to use 1. And they give a very complicated argument of why it should be 1. But if we use 0.2, this indicates that the risk for children, and particularly toddlers, children, adolescents, and the lifetime risk for non-cancer diseases is high. It's over the limit. But because the consultants chose to use 1, they've basically wiped away this risk. And the same with all of these other metals. Because they're saying 1 is the hazard, is the risk level, when in fact it should be 0.2. This puts nickel, lead, copper, certainly arsenic is already over the limit, and selenium. So it puts those metals at a level that will pose a risk to people living in Sudbury. Are these risk assessments sufficiently conservative? If you read the risk assessment done for Sudbury or Port Colborne or Baldoon, throughout the report, the risk assessors say this is conservative or overestimated the potential exposures, the absorptions, the amount of soil ingested, etc. We are being really conservative. But they do not factor in, the risk assessments do not look at your existing health levels. It doesn't factor in the disease and the cancer rates here. It doesn't look at the existing body burdens. It doesn't look at the lead level what's in children today. Because if they did, they wouldn't be advocating 400 parts per million. Because that would elevate their level of lead in their blood by 4 micrograms per deciliter. Just just like that.